instead of running StarWind Virtual Sun software on top of Windows bare metal, we've, as Max already told, we've virtualized everything in a VM. And we've passed through the Mellanox RDMA-capable NIC and the Optane into the VM directly. Because SRIOV still doesn't work properly in Windows, so we had to use pass-through. As soon as they fix it, it can be SRIOV. But for this purpose, it was a pass-through. And the VM is CentOS 7.5 with all the bells and whistles Max already told, having only 4 cores and 8 GB provision. Initiator remains completely the same. We start with Hyper-V Manager, just to check how the VM is provisioned. To go into settings. And see it's, 4 virtual processors and 8 GB of RAM. Now we go to initiator side. Doing the same check, no NVMe drives in the system. And now there is something you are not supposed to see, actually, because you are the first who will be seeing this. It's our new management system we call StarWind Stack, which will be used to manage all the hyperconverged infrastructure we offer. And you are the right people to see this anyways. So it will be released by the end of the year. So just a sneak peek during this demo. If you're interested, we can show it later at the end. A little bit maybe off-cam. So yeah, there are a lot of components. We are going to NVMe-oF control pane. A short overview of what we currently have in the system. No targets are configured. There are two servers in total. We go to manage, to add, to create the new target. So it's a Hyper-V server, the device, and the NQN is assigned automatically. It can be changed, obviously. Now we have created our target. The second step is to connect it to the initiator. We don't have to run the bash commands anymore, so we just beautifully click it, and yeah. Now the target is connected. We are tabbing back to the initiator. Checking the devices once again. Can see NVMe is present, so we can start benchmark. So I'll pause for a while. We are using, I guess, 32 QDEPs and 10 threads, just because these are empirical parameters, and I played a lot with it. And on this particular hardware, that's the configuration I could saturate it the most. So I could squeeze out the maximum performance. Yeah. That's why. From CPU to CPU and so on, it might differ, right? Just, yeah. And interesting stuff here. That's the Hyper-V server load. And you can see from 4 cores we have in the system, only 2 are working, and 2 are doing nothing. So it's, And we've got 555K IOPS in virtual machine running on top of Hyper-V.
What's the response time?
See it in the end. After the benchmark is finished, it shows the latency. So, on the virtual machine running on top of Hyper-V was our target. We've got 550K IOPS, accordingly better bandwidth, and the latency is lower. It's 0.57.
That's nice.
Kernel context switches are expensive.
Mm-hmm. Mm-hmm. As they should be.
How do I switch back?
To a degree,
There,
you know?
you got it.
There. OK. So, the same slide.
They burned 6
the
cores
V2 added,
kernel switch.
and you can see the difference. So, comparing to the Windows bare metal target one, where we've been utilizing 8 cores. In a virtual machine, a proper virtual machine, we have only 2 cores used, which leaves us 4 times more resources for applications and for all the stuff you
Aren't there virtual
should run,
kernel
right?
switches going on?
So that's an elegant solution, and the missing SPDK functionality that does it on Windows Server. So we are running it in a virtual machine with a proper operating system, and the first benefit is that CPU is used more efficiently, less latency. So instead of 8 cores, it's only 2, which is great. And another benefit we got is not very obvious, but it's portability. Because a virtual machine can be moved to another commercial or free hypervisor.
No.
So we go to the third demo, where we run the same, exactly the same virtual machine with our target on VMware vSphere. Changes here, obviously. Windows Server gone away. We have VMware ESXi 6.7 running bare metal. We have exactly the same VM with 4 cores and 8 GB of RAM running StarWind NVMe-oF fabric target. And the same technology is used. So we're SRIOV the network, because ESXi supports it. And we RDM, so directly pass through the drive to get the performance there.
Right, because I want you to own the drive, but I need to use the network card for other things.
Exactly. So we start with vSphere, go into our virtual machine. Yep. Just to check how it's configured. Yep. 4 CPU cores, 8 gig RAM. You can see the pass-through Optane drive there. Okay, switching to the initiator. Listing devices, no NVMe drive is connected. Just checking once again. Back to management. Go into NVMe-oF Fabric Control tab.
So again, you're running a server, in this case, vSphere server, and storage server, and a CentOS client.
Actually, in this demo, we have an CentOS client and 2 servers. I mean, one is ESXi, one is Hyper-V, and there are 2 VMs on top. So just I've configured everything just to record the demo, like without having to reconfigure the whole test bed. You know, you can see it. Can you just a little bit back?
What do you want?
Just a bit back while creating the target. Yes,
Here?
yes, that's good. So while we are adding the target, we can see the list of servers. One is Hyper-V, which was in previous demo, and one is ESXi. They are both present here. And yeah, while we're creating the target, we are choosing the proper server we need. And while connecting, there is only one initiator present. So there is not much choice. But anyways, you can manage a couple of servers and a couple of initiators simultaneously, just connecting them the way you want. So target is connected. Let's switch back to the initiator. Check if the drive is there. OK, target is connected. Drive is there. And we can start benchmarking. Same pattern. All settings remain the same. And it goes. So the CPU load, yeah, we have like, on a start, it's a bit better. It goes down then later. So we will see the middle. But still, we can see 2 cores are utilized at maximum, and 2 cores are still free on ESXi. So the same behavior as on Hyper-V.
And so your contention is that the 6 extra cores that are run bare metal are associated with kernel switching?
The 6 extra cores are associated with kernel switch, yeah. So that's the issue we couldn't get rid of because of Windows architecture. That's the problem.
Out of curiosity, did you test? I mean, you'd have to have written it beforehand, but was there any testing done where on the Linux side you weren't doing everything in userland? I'm just kind of curious as to how much of the benefit was the ability to move stuff into userland on Linux versus the way Linux handles things versus Windows. Because there was one before you showed the Linux VM on it and you had everything in userland. I was wondering if there was any previous version that didn't have everything in userland. I'm just curious as to where the benefit is.
The benefit is, you could see in the sum up diagram, right?
Yeah.
So it's around 30 or 40K IOPS, a higher bandwidth, and a higher CPU load. So it's a good product. It has its own users, but as we can see, if it's done properly, you can win much more, right?
Yep.